Hello guys, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. Problem number 3243, shortest distance after road addition queries 1. Okay, so I have already solved this problem in the past as well. I think in August month I have solved this problem in lead code weekly contest. Okay, both part 1 and part 2 of this problem. Okay, and today again I'm going to solve this. Okay, this part 1. Okay, I'm going to explain this in detail. Okay, so we have given an integer n and a 2D integer array queries. There are n cities numbered from 0 to n minus 1. Initially, there is a unidirectional road from city I to I plus 1. Okay, so here this city is 0, then next city is 1. So there is a one unidirectional road between them. Okay, from city I to I plus 1. Okay, and queries of represents the addition of new unidirectional road from city U to V. Okay, so initially it's like this. Okay, let's suppose there are total 3 cities. Okay, so this is a way. Okay, then there is a query 0 to 2. Then this simply means that there is one direct road from 0 to 2. Okay, after each query you need to find the length of the shortest path from city 0 to n minus 1. Okay, so this is going to be the shortest path. Okay, from 0 to 2, just one distance, right? Direct path. We have to return an answer array. Okay, where for each I in the range 0 to queries dot length of minus 1, answer of I is the length of the shortest path from city 0 to n minus 1 after processing the first I plus 1 queries. Okay, so see here in this example number 1, n is equal to 5, so we have cities from 0 to 4. Okay, and there is one unidirectional road between them, right? And then first we are going to process this query 2 to 4. Okay, so this is a short path. Okay, 2 to 4. Okay, so here what I'm going to do. So initially one thing is clear, right? uh, let's create one graph, right? So here we have cities 0 1 2 3 and 4. These are the cities that we have, right? And we know that from city 0 there is a path to city 1. Okay, so here I'm going to write it like this. City 1, there is one path and the distance is 1. Okay, distance is 1. 0 to 1, distance is 1 only, right? 0 to 1. Okay, from 1 there is a path to city 2 and distance between 1 and 2 is 1. Okay, so this is what I'm writing here, distance. Okay, now see here, from 2 to 3 there is one path. Okay, initially I haven't processed any query yet. Okay, so don't read these queries. Initially in the first case, when there is no path from 2 to 4. Okay, so from 2 to 3 there is one path with distance 1. Okay, or you can say weight or distance. Okay, so here I'm going to write 3 comma 1. Okay, and then from 3 to 4 we have one path, right? uh, and that is going to be 3 to 4. Okay, so here I'm just going to write 4 and 1. Okay, and for 4 that's it. Okay, there is no path here. Okay, so I have filled all these paths. Okay, 0 to 1 and 1 to 2, 2 to 3 there is one path, and then 3 to 4 there is one path. Okay, so this is done, right? So now after that, let's say I process this query. Okay, so here what it's saying, from city 2 there is a direct path to city 4. Okay, so 2 to 3 we are going, 2 to 4 also we can go, right? 4 and with the distance of 1 only. Okay, 2 to 4 direct path is there, so 4 and 1. Okay, so this is after first query. Okay, so here let's say that there is one array. Okay, there is a array which I'm going to fill. Okay, so this is for city 0, city 1, city 2, city 3, right? And city 4. Okay, so now here if you see now, uh, 0 to 0. Okay, 0 to 0 I'm I'm at city 0 only. 0 to 0 if I'm moving, so I'm going to, let's fill it with 0 only. Okay, and let's say from 0 to 1 if I'm moving, let's say distance is infinity right now. Okay, distance is infinity. Okay, I want to reach from 0 to 4. Okay, so I am initially at 0 only. Okay, so that is why I'm writing 0 here, and for others I am feeling infinity right now. Okay, I don't know the minimum distance. Okay, 0 to 4. So here at this point I need one value, okay, minimum value at this point while reaching from 0 to 4. Okay, so now I have processed this query. Okay, so initially here 0 to 1 I can move, right? So here what I'm going to do, 0 to 1 I can move, right? So here I'm going to take one priority queue as well. Okay, and in the priority queue I'm just going to add the next city and the distance. Okay, and this priority queue I'm going to implement it using minimum heap. So with whatever value is minimum here, I'm going to write it on the top. Okay, here, so this is going to be my next city, and this is going to be the weight. Okay, or distance, you can say anything. Okay, so initially I am at 0 by 0, so I am just going to add 0 by 0 in my priority queue. Okay, right, this is done. Now I'm going to run one while loop until my priority queue is not empty. Okay, so here I'm just going to pop this element out of my priority queue, 0 by 0. Okay, so 0 is nothing but my city, and this is nothing but distance. Okay, initially source is here. Okay, now 0, I know from for 0 the neighbors are this. Okay, for 0 neighbors are this 1 and 1. Okay, so that simply means that there is one path from 0 to 1. Okay, so here 0 to 1, if I move here I'm writing infinity, but this is best case now. If I can write 1 as well, right? So here let's write 1. Okay, because to move from 0 to 1 the distance is not infinity, it is just 1, right? So here I'm just going to write it with the 1. Okay, this is done. All right, now this is done. Now just do one thing here, write my next city. Okay, I'm just going to add my next, which is nothing but 1. Okay, and the distance to reach this 1 from 0 is 1. Okay, I have added this. Okay, now again my priority queue is not empty. Okay, so I'm going to pop this. Okay, and I'm going to solve this 1 and 1. This is nothing but my city, this is nothing but my distance. Okay, so now from 1 I can move to 2, right? From 1 I can move to 2, and the total distance is going to be 2. Why 2? Because I am starting from 0 to 1. If I move here 1, then 1 to 2 I am moving, so distance will be incremented by 1. Okay, so here instead of writing infinity I am going to update with the 2, right? So 0 I am calculating 0. Okay, 0 to 1, then 1 to 2, if I move to 2. Okay, so here for this distance at city 2 I am reaching with the 2 distance total. Okay, this is done. Now after that I'm just going to pop this 2 by 2. Okay, out of this now I'm going to solve this 2 by 2. Okay, so 2 and 2 here. Okay, so now from 2 what are the neighbors? These are the neighbors, 3 1 and 4 1. Okay, so here 2 to 3. Okay, first I will check 2 to 3 I am moving with distance as 1. Okay, so 2 to 3 simply means here 1. Okay, 2 to 3 is 1, and previously it's 2 until here. So here I can simply write 3. Okay, so it is correct, right? 0 to 1 1, 1 to 2 2, 2 to 3 1 again, so total 3. Okay, so that is why writing 3. Okay, and just add this 3 by 1 here. The 3 by 3 we need to write here. This is the total distance starting from 0, total distance, and this is nothing but my city. Okay, so this I have added, and there is one more neighbor for this one, 4 1. Okay, so here 2 to 4 also I'm going with 1. Okay, so here 0 to 1 1, 1 to 2 1, and 2 to 4 is also 1. So here I'm simply going to update it with 3. Okay, so here city 4 and I'm reaching in a 3. Okay, so 4 I'm adding here and 3. Okay, so by default this will come to the top. Okay, otherwise if this is minimum then I should keep it at top, but both are same, then the first process will come to the top. Okay, first I process this, then it's come to the top. Okay, so this is done. All right, so now here pop this 3 by 3, pop this out, and now solve this 3 by 3, 3 by 3. Okay, so from 3 to 4 I want to move. Okay, so 3 to 4, now see carefully, 3 to 4 I am moving. So here value is 3 initially, but here if I move like this, 1 here, 1 here, 1 here, 1 here, the value is coming to as 4, but here it is 3. So this 3 is minimum, so I'm not going to touch it. Okay, I'm not going to touch it because this is 3, this is minimum one only. I'm not going to update this 3 with 4. Okay, 4 is greater than 3, so I'm not going to update. Only if I get some minimum value then I will update it this path. Okay, otherwise not. So I'm not going to update it. Okay, so I have solved it, nothing. I'm not going to do anything later. Okay, now after that I'm still left with the 4 3. Okay, let's solve this. 4 and 3. For 4 and 3 there are no neighbors. Okay, so there is nothing, so we are not going to do anything. Okay, and in the end what I need to do, I process all the elements. Now my queue is empty. Okay, now my queue is empty. Okay, I have processed all these. So yeah, this priority queue is empty. Okay, so now what I'm going to do, so in the end add this index. Okay, so 0 to, we are moving to 0 to 4 now. So in the end, see here we are getting 3, so that is why I'm writing 3 here in the first part with only this query 2 to 4. Okay, this is done. 2 to 4, we are good, right? Now next time again, there is one path from 0 to 2. Okay, so what I'm going to do, so you know that how we are getting 3. So here this is how we are getting 3. Okay, so same thing we need to do. Okay, so now from 0 to 2 there is one path. Okay, so here I can simply write, I can move from 0 to 2 with distance as 1. Okay, with 1. Okay, 1 I'm writing because there is direct path. 0 to 2 there is one direct path, so here I'm writing 2 and 1. Now again I have to solve this again, same process that I've explained here. Create this. Okay, and create one priority queue and then insert the values. Okay, and in the end whatever the value that is there in the at the end position, just fill that. Okay, so this is the same thing that I need to do. Okay, so now I'm going to write the code, and while writing the code I'm also going to explain few things. Okay, and I know that with code you guys will get much better understanding. You guys are already clear, but with code you guys will get much better understanding. Final int infinity is equal to integer dot max underscore value. Okay, and then create one distances array. Okay, distances array new int queries dot length. Okay, queries dot length. All right, now after that create one map. Okay, and map is consisting of what? Map is consisting of integers and the list of int arrays. Okay, list of int arrays, list of int arrays. Okay, so here map of integer as key and list of integer. Okay, you can write it like this now, int. Okay, list of int, you can say graph. Okay, is equal to new hash map. All right, so this is done, right? And then after that what I'm going to do, I'm going to write this 0 to 4 first. 0 to 4, all these keys first. Okay, so here what I'm going to write, for int I is equal to 0, I is less than n minus 1. Okay, so we actually don't need this. Okay, we actually don't need this, so let's write it until here because this is my last final city now. From there is no other path, right? So why writing for here? So that is why I'm just simply going to write I is less than n minus 1. Okay, and I plus plus. Okay, so now here graph. Okay, the graph that I have, which consists of list of int arrays. Okay, so in the graph first I'm going to put my key. Okay, the key that I have, this key 0 first I'm putting, then 1. Okay, and these keys consist of, let's say initially there is one array list only. Okay, there is nothing inside this array list but empty array list. Okay, so new array list. Okay, this is done. Okay, now after that, once this is done, then again run one loop for int I is equal to 0, I is less than n minus 1, I plus plus. Okay, and now inside this graph. Okay, graph dot get the particular key. Okay, let's say 0, and in this 0 I'm just going to add what? I'm going to add the array. Okay, and initially how my arrays are added, so first we have to add this 1 1 2 1 3 1 4 1. Okay, this is what we need to add. Okay, direct pass we need to add first. When right now we haven't processed any queries, we are just adding direct path in my graph. Okay, so here new int, so how the paths are like, so here for 0 we are writing 1, here 1 we are writing 2, here for 2 we are writing 3, here for 3 we are writing 4. Okay, so here I'm just going to write I plus 1, and here I'm just going to write 1. Okay, that's it. So this is clear. Okay, this is done here. Then after that, now we have to process the queries one by one. Okay, so first 2 for query. Okay, so here what I'm going to do, just iterate over all the queries that I have. Okay, so simple story that I've done. I'm going to write the simple story step by step. For int I is equal to 0, I is less than queries dot length. Okay, I plus plus, and pick first query. Okay, 2 for first query. So here int query, first query I'm going to just pick. Okay, queries of I, just assign that to my variable, right? This query variable. Okay, so this query has two values. Okay, one is starting point and one is ending point. So here I'm just going to write u is the starting, let's say. So query of 0. Okay, and v is equal to query of 1. Okay, now this is my u, I'm saying, and this is nothing but my v. Okay, so this is done, and then we have to put this to a graph. Okay, so graph dot get u. Okay, and add new int. Okay, and here we have to write v and 1. Okay, so this is what we need to write, right? So here 2 to 4 there is one path. So what I'm writing 4 and 1 for this key 2. Okay, so this is what I'm doing. All right, now after that take one priority queue. Okay, and in priority queue what we are adding, we are adding the arrays, right? And here let's just name it as pq. Okay, new priority queue. Okay, and the comparator operator. Okay, I want min heap here, so that is why I have to use that based on the second values that we have. Okay, comparator dot comparing int, and we have to write just a of 1 because we are comparing the second value. Okay, the distance value that we have. Okay, this is done. Here it should not be dot, that's why it's coming as red. Okay, comma we need to use. Okay, this is done. Okay, we are writing 4 comma 1. Okay, so by mistake I put dot here, that is why it was coming as red. Okay, now after that pq dot add new int. Okay, so initially in the particular I told you guys that we have to add 0 0. Initially we are at this source and the distance to that particular source is 0 only. 0 to 0 distance is 0 only, right? So this is done. Okay, then min distance array that we need. Okay, create one min distance array. Min distance array new int n. Okay, and initially we are just going to fill all the values to the infinity. Okay, arrays dot fill min distance, and here inf. Okay, so until here we are done. Okay, so I have filled all these to infinity infinity infinity. Okay, this is done, right? Now here one more thing, we filled all these to infinity, set it to 0 as well. Okay, 0 to 0 distance 0 only. So here min distance 0 is equal to 0. All right, and then run one while loop. pq is empty. Okay, and here take that particular node. Okay, and here just pour that elements of my priority. Okay, 0 by 0 what I did. Okay, I'm just going to pour that. Okay, now from this source to destination I have to find out, right? So here int u node, okay, is equal to node of 0. All right, and int u distance is equal to node of 1. Okay, and now we have to check particular neighbors of my u node. Okay, so for int neighbor. Okay, so here graph dot get u node. Okay, now here int v node is equal to neighbor of 0, and weight is equal to neighbor of 1. Okay, so this is what right, 0 by 0 I'm taking initially. Okay, 0 by 0 I took, then for this 0 neighbors are this 1 by 1. Okay, so here I'm taking this and this. Okay, so if there is any other neighbor, I'm going to take that as well. Okay, so I'm just going to iterate over all the neighbors one by one. Okay, so here we are just going to up check if, so here I'm checking if like from 3 to 4 if I'm moving and I'm getting 4 here. Okay, I'm checking this 4 if this 4 is less than the previous value at this particular position. Okay, if it is less than, then place that value, otherwise not place that value. Okay, so here that's what we need to check. Mean distance of u node, okay, plus weight. If it is less than, mean distance of v node. Okay, so in that case only we need to update. Okay, so here what I'm going to write, mean distance of v node is equal to mean distance of u node plus weight. All right, so this is what I have explained in the story, right? And only in this case we have to add the element to our priority queue. Okay, so here I'm just going to write priority queue dot add new int, right? And here first is going to be v node in my array, and at second index I'm just going to pass min distance of v node. Okay, all right, so this is done, right? So here I'm just going to write distance sys of I is equal to mean distance at last, okay, last index 0 to n minus 1. Okay, last index, right? So that is what we need to write here, and in the end just return the distances. Okay, distances array. All right, so now let's run it and see if there are any code issues, then we'll try to fix that. Okay, so see here we are getting this error. Okay, because here for the 3 I'm checking the neighbor 4, right? And for this neighbor 4 later on I will check the possible neighbors, right? So here that is why we are getting this null exception. Okay, so here instead of that let's create this. Okay, let's create one array list for that one. So now I think it will work, so let's run it. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.